Good morning, everyone. So today, I am going to discuss the basic logic gates. Digital systems are said to be constructed by logic gates. These gates are the AND, OR, NAND, NOR, EXOR, and EXNOR gates. The basic operations are described below within the aid of truth tables. AND gate. It is an electronic circuit that gives a high output if only if all its inputs are high. A dot is used to show and the AND operations, which has the example A dot B dot. Bear in mind that this dot is sometimes omitted. Example is A B without the dot. As you can see, AND gate has an input A and input B, and it has a 1 output. So it has also the table to show the illustration. OR gate. The OR gate is an electric circuit that gives a high output if one or more of inputs are high. A plus is used to show the OR operation. So as you can see in the illustration, we have here input A, input B, and it has an output. And it also has the equivalent circuit below. NOT gate. A NOT gate is an electronic circuit that produces an inverted version of the input at its output. It is also known as A or A with a bar over the top as shown in the outputs. The diagram below or beside shows two ways that a NAND logic gate can be figured to produce a NOT gate. It can also be done using NOR logic gates in the same way. So we have here the NOT gate. We have the symbol A and C with the A with the top bar over, and it also has the truth table beside it. NAND gate. This is a NOT AND gate, which is equal to an AND gate followed by an NOT gate. The outputs of all the NAND gates are high if any of the inputs are low. The symbol is an AND gate with a small circle on the output. The small circle represents inversion. So for the illustration here, we have the input A and B, and the outcome, it has the circle which represents the inversion, and the C here represents the A dot B. And for the truth table, we can see the inputs and the outputs. NOR gate. This is a NOT OR gate, which is equal to an OR gate followed by a NOT gate. The outputs of all NOR gates are low if any of the outputs are high. Inputs rather are high. The symbol is an OR gate with a small circle on the output. The small circle represents inversion. Just like the previous one, the small circle also represents inversion in the NOR gate. We have here the input A and input B and the outcome. And for the truth table, it also has the datas. EXOR gate. The exclusive OR gate is a circuit which will give a high output if either but not both of its two inputs are high. An encircled plus sign is used in the EOR operation. In the illustration here, it has the input A and B and the XOR, and the outcome is A with the use operation plus with the circle B. And it also has an input and output illustration as shown in the table. EXNOR gate. The exclusive NOR gate It will give a low input if either but not both of its two inputs are high. The symbol is an EXOR gate with a small circle on the output. The small circle represents inversion. The NAND and NOR gates are called universal functions since with either one the AND and OR functions and NOT can be granted. In here in the illustration we can see the input A and input B with its the output has the small circle which also represents the inversion. In the table here we can see the input and outputs of the EX and OR gate. We have to note that a function is a sum of products form that can be implemented using NAND gates by replacing all AND and or OR gates by NAND gates. A function is a product of sums form can be implemented using NAND gates replacing all AND and OR gates by NOR gates. So that's all for the basic logic gates.